Welcome to a new episode of the podcast. Fox Agent is made by AI for business executives that work with AI. Today we're doing a deep dive, really getting into something our sources are calling the essential foundational connective tissue for next-gen enterprise AI. We're talking about knowledge graphs, KGs. Now, for years, these were maybe seen as a bit niche, a specialized data tool. But what we're seeing now, what the research shows, is they're driving a huge strategic shift. They're letting companies push AI way beyond just spotting patterns. We're moving towards what's being called agentic AI. Think systems that can actually reason, understand context, and act. Sophisticated stuff.
Yeah, and if you're an executive, maybe feeling the heat to get generative AI deployed, but deployed responsibly, this is, well, it's critical. Because standalone large language models, LLMs, they're powerful, no doubt, transformative. But they have real problems in a serious business context. They struggle with factual consistency, they hallucinate, make things up, and their knowledge is basically static, right? It doesn't reflect your real-time operations.
Right, not ideal for high-stakes decisions.
Yeah. Exactly. Whether it's risk or customer engagement or even diagnostics, you need reliability. You need the certainty. KGs, they offer a solution here. They provide this structured, verifiable, dynamic source of truth, a way to ground the AI's output. So the recommendations become transparent. You could audit them. They're reliable. We're shifting, really, from just probabilistic guesses to actual evidence-based intelligence.
Okay, let's unpack this then. If KGs are this foundation, how are they really different from, say, the traditional databases we've all been using for decades? Why this whole new layer?
It's a good question. The difference is pretty fundamental, both architecturally and philosophically, you could say. Your traditional databases, relational ones, even document stores, they basically treat data as isolated facts, stored in rigid tables, often in silos. A knowledge graph, though, it's built differently. It's designed as a network. Its whole purpose is to model the real world, the relationships between things. It doesn't just store data. It stores the meaning, the connections.
The connections themselves are data.
Precisely.
Yeah.
And there are three core parts. First, you have entities. These are the nodes in the network. They represent your real-world concepts, customers, products, transactions, regulations, whatever matters to your business. Second, you've got the edges, or relationships. These are the links between the entities. And they're semantic, they have meaning, like is located in, or manufactures, or reports to.
Okay, so entities and the relationships connecting them.
Right. And the third piece, which is strategically vital, is the ontology. You can think of the ontology as the formal grammar, maybe, the rule book for the graph.
The rule book?
Yeah, it defines what types of entities can exist and, crucially, how they're allowed to relate to each other. This ensures consistency. It provides the logical guardrails the AI needs to reason reliably. The graph's value isn't in the individual nodes. It's entirely contextual. It comes from being able to, traverse those connections, turning simple data points into actual structured intelligence.
Let's make that more concrete, that contextual value, because siloed data, it can seem fine, right? Until you hit something complex, some hidden risk. Can you give an example of that multi-hop reasoning you mentioned, maybe in risk management?
Absolutely. Let's take something like a sophisticated financial crime, maybe a coordinated insurance fraud ring.
Okay.
A traditional system, looking at transactions one by one, might flag an odd claim amount, or maybe a questionable address, a single data point, basically.
Right, isolated flags.
But a knowledge graph lets an AI agent perform what we call complex multi-hop reasoning. It connects the dots, many dots, potentially. So the agent sees that flagged claim, that's an entity, it links it to the claimant entity, then boom, it instantly traverses the relationships. Does this claimant share an IP address with 5 other recent claimants? Do they all use the same repair shop? Maybe the same unique device ID, but registered to a different address.
So patterns across seemingly unrelated claims.
Exactly. Individually, none of those might trigger a major alarm. But the graph, it visualizes that coordinated network almost instantly. It identifies the whole ring structure in milliseconds. That lets the business block the systemic risk, not just one dodgy transaction. That kind of speed, that contextual depth. You just can't get that from conventional siloed data structures.
Okay, here's where it gets really interesting, I think. We're moving beyond just data management into, like you said, AI architecture. We know LLMs are fluent, they're creative, powerful, but they have this opacity problem, this hallucination issue. Adding a KG sounds like a lot more complexity.
Yeah.
Why not just feed the LLM more and more data? Why build this whole separate graph structure?
That's the million-dollar question for executives, isn't it? Why the overhead? The short answer is verifiability and governance. LLMs are trained on these massive static data sets. They're amazing at generating human-like text, but fundamentally, they have no idea what's a real fact from your company's books versus a plausible-sounding fabrication.
Right. Confidence doesn't equal correctness.
Precisely. The KG fixes that. It acts as the factual, verifiable ground truth. It's like an external, up-to-the-second business memory for the AI agent. And the main way they work together, the symbiotic relationship, is through a technique called retrieval augmented generation, RA. You've probably heard of it.
RA, yeah. Heard the term.
So RE is the mechanism that keeps the LLM's creativity tethered to reality. When an AI agent gets a query, let's say a manager asks, assess the risk of onboarding vendor X. The agent doesn't just pass that question straight to the LLM. No. First, it translates that natural language query into a structured query for the knowledge graph.
Okay, so it queries the KG first. What does it get back?
It gets back a very specific fact-checked subgraph, just the entities and relationships directly relevant to that vendor. Their known risks, maybe supply chain partners, compliance records, only the verified facts.
Got it. A focused chunk of verified data.
Exactly. And that subgraph, that verified data, is then inserted directly into the prompt that goes to the LLM. It becomes the context. So the LLM generates the answer, the risk assessment, but it's forced to base its synthesis only on the facts provided by the KG.
Ah, I see.
This massively cuts down on factual errors. It avoids relying on old training data. And critically, the final output. It can always be traced back to the specific nodes and edges in the graph that were used. You get full explainability.
So the graph provides the guardrails, the memory, the audit trail, essentially. But the LLM still handles the fluent explanation. And our sources suggest that this isn't just a one-way street, right? The agents don't just read the graph, they actually help improve it.
That's right. It creates this really powerful continuous learning loop. We're seeing advanced multi-agent LLM systems being used now to actually manage the KG lifecycle. Think about it. These agents can monitor floods of unstructured data, internal reports, technical docs, competitor news, stuff that used to just sit there. They can automatically identify and extract new entities and relationships from that text. Then they can propose updates or enrichments to the knowledge graph, maybe flag it for human review, maybe automatically integrate it based on confidence scores.
So the agents keep the graph current.
Exactly. The KG stays up to date, it gets more robust, and then in turn, that newly enriched KG provides better, more accurate context back to the AI agents using it.
Making them smarter and more grounded.
It's a virtuous cycle. Context, verification, automated maintenance, really powerful.
Okay, if we connect this to the bigger picture, where is this actually delivering, measurable results, quantifiable ROI today?
Well, the impact is definitely clearest in industries where understanding complex relationships is absolutely critical for managing high-stakes risk and reward. Take financial services. KGs are fundamentally changing compliance and fraud detection. It's shifting the whole game from just reacting to fraud after it happened
to proactively modeling the risk before it crystallizes.
Exactly. By connecting the dots between customers, legal entities, device IDs, transaction flows, all that stuff,
Right.
Organizations are uncovering sophisticated money laundering rings, market manipulation schemes, things that would take human analysts weeks or months to piece together, if ever.
And the KG spots it almost instantly.
Instantly. This cuts down regulatory exposure, reduces operational losses. The ROI there is pretty clear. And you look at healthcare and life sciences. The shift there is towards truly personalized medicine. Medical KGs are integrating data silos that were basically impossible to connect before.
Like what?
Electronic health records, patient genomic data, medical imaging results, the entire corpus of clinical trial literature, all structured together.
Wow.
By structuring all that context, AI diagnostic tools can move beyond just generalized recommendations. We're seeing AI recommend highly personalized treatment plans with much better predictive accuracy. It can optimize drug interaction analysis, speed up clinical trial reviews significantly. It's really promising.
That focus on the human impact, especially in healthcare, brings up a really critical strategic point.
Yeah.
Fairness.
Algorithmic bias is a huge concern for executives' legal risks, PR nightmares. How do KGs help address that bias problem that we know LLMs often inherit from their general training data?
This is actually a major governance advantage of using KGs. You're right, LLMs trained on broad web data, they inevitably soak up historical and societal biases. KGs give the enterprise a way to explicitly counteract or compensate for those biases.
Oh.
By formally modeling factors that influence outcomes but aren't typically in standard data sets. Take social determinants of health. SDOH. Things like neighborhood safety, access to healthy food, housing stability,
Yeah.
factors we know impact health outcomes.
Right, the real-world context. By building these SDOH factors directly into the clinical prediction models within the graph, the organization can ensure its AI recommendations are more equitable. The graph makes potential biases visible and manageable because it structures the context. It can help counter unfair associations the general LLM might otherwise make based on biased training data. This leads to fairer, more ethical, and frankly, more compliant AI systems.
Okay, so what does this all mean strategically for executives who are listening and thinking, right, we need an enterprise knowledge graph? Because building this across a big, complex organization, that sounds like a heavy lift.
Oh, it is. Let's be clear. It's a significant undertaking. And the main challenges, interestingly, are often non-technical. They require real executive focus. First up is governance and integrity. A KG is only as good as the data feeding it and the rigor of its ontology, that rulebook we talked about.
Garbage in, garbage out, but amplified.
Exactly, exponentially amplified. Executives have to commit resources to continuous data integration, to resolving conflicts between entities coming from dozens of different legacy systems. And rigorous management of that ontology is non-negotiable. If the input data is messy or the defined relationships are flawed, the AI decisions built on top will scale those flaws dramatically.
Okay, governance first. What else?
Second big challenge is legacy systems and talent. Most large companies are running on a patchwork of older, heterogeneous systems, integrating all of those to feed a single, unified graph layer. That's resource-intensive. It takes time and money. And this is compounded by a real scarcity of specialized talent. You need ontology engineers, semantic data architects, graph database experts. These are not common skill sets yet. So you need a serious human capital strategy alongside the tech investment.
Right, the people problem.
And finally, there's what I'd call the explainability challenge. Now, KGs are entirely transparent, right? You can trace the reasoning path the AI took through the graph.
Which is better than a black box LLM.
Definitely. But that reasoning path, especially for complex multi-hop queries across millions or billions of nodes, it can still result in an incredibly dense, convoluted subgraph. Imagine a business user gets an alert. We flagged this multi-million-dollar loan because of a risk score derived from 23 interconnected entities. That's not very helpful on its own.
Yeah, they need the so what.
Precisely. They need that complex graph path translated into plain business language, not just a messy visualization. So the enterprise needs tools and processes to simplify and communicate that explanation effectively.
Okay, so significant hurdles. Governance, legacy systems, talent, and making the explanations truly usable. But despite that, it sounds like the competitive advantage lies with companies pushing forward here. What's the end game? What's the big strategic asset being built?
What forward-thinking organizations are building is moving towards what's being called the Enterprise Knowledge Fabric, EKF.
Knowledge fabric. Okay.
Yeah. The future isn't just static, monolithic graphs. It's about dynamic, real-time, and crucially, multimodal graphs. Graphs that integrate all kinds of enterprise data, not just text and structured data, but images, video feeds, streaming IoT data, everything, all woven together into a unified, real-time, semantic layer. The EKF essentially becomes a living digital twin of the entire organization.
Wow. A digital twin based on meaning and connections.
Exactly. And when you have that, the KG shifts from being just another database component to becoming the core strategic asset. It's the canonical, context-rich data layer you need to build truly resilient, adaptive operations. And it's what will unlock those highly autonomous, self-directing AI agent systems everyone's talking about.
That integrated, dynamic view that really feels like the game changer. So our deep dive today really underscores it. Knowledge graphs aren't just some niche tech anymore. They're fundamental. They turn static data silos into this dynamic, interconnected, actionable intelligence. They provide that essential contextual backbone you need for reliable, explainable, and ultimately trustworthy agentic AI, especially in those really critical business areas.
Absolutely. And maybe one final thought to leave executives with, connecting back to strategy. Defining and building an enterprise knowledge graph. It's not just a technical project. It's a profound strategic exercise in corporate governance. It forces the organization, perhaps for the first time, to formally define not just its data elements, but its entire operating worldview. How do our core entities actually interact? What constitutes risk for us? How do we really measure success? That ontology, that structure, it becomes a codification of the organization's collective intelligence and strategy. And that codified worldview, that becomes arguably the most valuable layer in your entire AI stack.
A codification of the organization's worldview. That's a powerful way to put it. Thank you for joining the podcast, and see you soon.